Hi students, welcome to physics classes. Now in the part of electric current, in the last video we discussed up to electric shock. Now we will continue with the activities related to resistance. If anybody didn't see that videos, I'll give the links in the group description. You can see that. Now resistance. Resistance means generally we know the meaning of the resistance. Something is opposed. Resistance. Something is opposed. Here in electric current, resistance means it opposes the flow of electric current. Means it obstructs the motion of the electrons. Then we'll get the required amount of current. We'll get the required amount of current. Resistance is offered by a device resistor, and we can denote with R, and the resistor symbol will be like this, resistor. Now this resistance is affected by different factors that we will discuss now. Factors affecting the resistance of a material. First one, temperature. Resistance depends on the temperature. If temperature is changes, resistance also changes. Next, nature of the material. Nature of the material. Nature of the material. Nature of the material means, for example, if you take silver, it will have some resistance. Copper, it will have some resistance. Iron, it will have different resistance. Like that, based on the nature of the material, resistance will be changes. Resistance will be changes. Next, length of the conductor. Now, conductor length also influences the resistance. If 10 centimeters length, 20 centimeters length, 5 centimeters length, as the length varies, resistance also changes. Next, area of the conductors, area of cross section. Conductor, area of cross section of the conductor. Simply we can say it is thickness. As thickness of the conductor changes, flow of electric current will changes. That means resistance also changes. Resistance also changes. Now resistance is depends on four factors. First one is temperature. Next one is nature of the material. Next is length of the conductor. Area of cross section of the conductors. These are the activities. Each one will discuss detailedly. Simple activities, and you will get good marks in the exam. Now first, temperature. We will see the temperature. Whenever we are considering in any one factor like this temperature, remaining three should be constant. Whenever we are taking temperature is considered, temperature should be changes. Material should not be changed, length of the conductor should not be changed, area also should not be changed. Only temperature should be changed, remaining all should be constant. Temperature. Now you'll ask in the exam, write an activity to show that resistance of the conductor depends on temperature. Write an activity to show that resistance of the conductor depends on temperature. Now we will discuss in the form of activity. Now we'll write aim to show that resistance of the material depends on the temperature, and the materials required, whatever the materials required, that we will write, and then procedure, finally observation, result. In the form of activity we should write. then examiner gets impressed and will give you good marks. Now aim, whatever the question they asked, that becomes the aim. For example, in the question, write an activity to show that resistance of the material depends upon the temperature. Aim to show that resistance of the material depends on the temperature. Materials required. Now before writing materials required, I will tell you the circuit diagrams. If you remember the circuit diagram, then you can identify the what are the materials in that, then you can write directly. We need a bulb. To allow the electric current, we should connect the battery or cell. There should be a switch. Ammeter to measure the electric current. These are the wires connected. And a multimeter to measure the potential difference. Resistance also we can measure. Multi-purpose. Multimeter, multi-purpose we can use. Now you can write the materials required. Bulb, battery, switch, ammeter. Ammeter also available in the multimeter. Directly you can write multimeter. Now while connecting, these are the materials required. We will write there. Then after, procedure. Yes, before connecting the circuit, one thing we should do. We will measure the resistance of the bulb. We will measure the resistance of the bulb by using multimeter. First we will find before connecting to the circuit. Before connecting in the circuit, we should measure the resistance of the bulb. We should measure the resistance of the bulb by using multimeter. That we will write in the book. Resistance before connection. Some ohms, that we will write. Some X. Now we will keep the bulb in the circuit and we will switch on the circuit, and the current will be flowing through that. Bulb will close for some time. After few minutes, again we will measure the resistance of the bulb. Resistance after. Some Y ohms, that we will write in the notebook. That is the procedure. First, we have taken the bulb before connecting to the circuit and measured its resistance and connected and switch on. Electricity is flowing through the bulb. It will glow, and after some time, few minutes later, we will measure resistance of the bulb and we will write down in the notes. That is the procedure. Now what we observed here. Initially, before connecting to the bulb, we measure the resistance, and after connecting to the bulb, we measure the resistance. Now we can say that when compared to the first case, second case, resistance of the bulb is more. Resistance of the bulb is more when compared to the first case, second case. And compared to the first case, in second case, resistance of the bulb is more. That is why when we take the in open circuit and if you measure the resistance, its temperature is less, room temperature. Its temperature is less, nearly room temperature. After connecting to the circuit, its temperature becomes more. Its temperature becomes more because of the heat generated in the circuit. The bulb will glow, no? Then heat is generated. Then due to that temperature is increased. Whenever temperature is increased, resistance increased. Then what we observed here, when compared to the first case, second case is more temperature, so more resistance. Resistance is more. Whenever temperature is increased, result, what we can say the result, whenever temperature is increased, resistance also increased. Temperature is increased, resistance also increased. Okay. Now, next activity, resistance of the conductor depends on nature of the material. Resistance of the conductor depends on nature of the material. Now, to do this experiment, we need this type of circuit diagram. Here P and Q not connected, and wires, electric wires, copper wires, battery, ammeter, switch. Now here we should join the materials for which we want to check whether the nature of material depends on resistance depends on nature of material or not. Now here we are taking copper, nichrome, manganese wires of same length, same area of cross section, and should be in same temperature. Last activity we seen, whenever we are taking temperature is consideration, material should be same and the same length, same area. Now we are taking nature is consideration, remaining three, length, area, temperature should be same. That should not influence anything. Same length we should take. Copper of same length, nichrome of same length, and manganese wire of same length we have to take. And we should connect each one here between P and Q, between P and Q. Now we will measure the current flowing through that. If more current is coming, less is the resistance. Less current is coming, more is the resistance. Like that we will measure the resistance in the notebook. When we do these three, each one is showing different resistances. Each one is showing different resistance. No one is matched. It is having some resistance, it is having some resistance, it is having some other resistance. So here when the material is changed in the conductor, resistance also changing. When material is changed in the conductor, resistance also changed. So we can say resistance of the conductor is depends on nature of the material. Resistance of the conductor depends on the nature of the material. When we connect copper, we are getting one resistance. We are connecting nichrome, another one. Manganese wire, another resistance. Means whenever the material is changed in the circuit, resistance also changed. Resistance also changed. So we can say resistance depends on nature of the material. Okay. Now length of the conductor. Resistance of the material depends on length of the conductor. Resistance of the material depends on length of the conductor. Now here length. When we consider length, when we consider any one of the characteristics, remaining should be constant, I told you. Whenever we consider length, nature of the material should be constant. Means the same material we should take. Same material we should take. Length considered, no, so different lengths we should take. From this manganese, nichrome, copper, any one only we should take. Any one we should take, and each one have different length. Different length. Either one is 10 centimeters, another one is 15 centimeters, another one is 20 centimeters. For example, if you take manganese wire, of 10 centimeters, manganese of 15 centimeters, manganese of 20 centimeters. Everyone should be manganese, but length will be different. And next area should be same. area should be same, and temperature also same thing we should take. But only the thing we should change the length of the conductor. As we considered, we are checking whether length is depends or not. Now previously whatever circuit we have taken, same circuit we have taken. PQ is not connected and P is connected to battery to ammeter to followed by switch next Q. Now between these two we should connect magnet of 10 centimeters, and we will measure the flow of current or resistance in the notebook, and next replaced with 15 centimeters and measure the resistance, and the next 20 centimeters and measure the resistance. Whenever length is increasing, here we can observe that whenever the length is increasing, resistance of the material also increases. Length is increasing, resistance of the material also increasing. So we can say that resistance of the conductor is directly proportional to length of the material. Resistance of the conductor is directly proportional to length of the material or conductor. Whenever we have taken constant temperature, constant area, constant temperature, constant area, and material should be same material, nature should be same. Resistance of the conductor directly proportional to length of the conductor. Whenever more length, if length is more, resistance also more. Whenever length is more, resistance also more. So we can say resistance is directly proportional to length, and the length of the conductor influences the resistance. Resistance is depends on length of the conductor. Resistance is depends on length of the conductor. Now next one, cross section area. Cross section area, resistance of the conductor depends on cross sectional area. Means same material, like previous for length what we have taken, same material we should take, and here length we should take same length we should take, same nature we should take, and same temperature. Same length, same nature, same temperature we should take. What should be the difference? Area should be different. Area is different. Area is different. Means thickness will be different. Material should be same. Now we are taking manganese wire. Different area of cross section. Like previously what we did, like that only we should join here manganese wire of different areas. For example, we have taken A, B, C, 3 different materials. One is having more, less, still less. Like that we should join between P and Q. Whenever we connected more thickness, current is flowing more, resistance is less. Whenever we join less thickness, current is going less, more resistance. I'll repeat. Whenever we connect more thickness, more area of cross section, more current is flowing. As thickness is more, current is flowing more, resistance is less is the resistance. Whenever we connected less area of cross section, resistance is more. So here resistance is inversely proportional to area of cross section. Resistance is inversely proportional to area of cross section. Whenever area is more, resistance is less. Area is less, resistance is more. So here area of the cross section will influences the resistance of the conductor. And or we can say resistance is depends on area of cross section. These are the activities which are very important, and most of the times they are asking in the exams length and area. Length and area. Whenever we write these two activities, we should not leave here. We should continue some other more. As we got resistance is directly proportional to length, equation 1. Resistance is inversely proportional to area of cross section, equation 2. While combining these two equations, resistance is directly proportional to length and inversely proportional to area. To remove the proportionality symbol, we should take one constant r equal to rho. It is not p. It is not p. It is a rho. L by a. Rho means proportionality constant. We can take it is resistivity. It is resistivity. R equal to rho L by a. Rho means resistivity. Now we can write rho equal to, while a is coming this side, R A by L. R A by L. R units ohm, A units meter square, by L unit meter. Meter gets cancelled. Ohm meter. Units of the resistivity. Units of resistivity. Ohm meters. Sometimes they are asking this derivation separately. Derive R equal to rho L by A or rho equal to RA by L. Okay. Now resistivity. Resistivity is denoted by letter rho. Rho equal to RA by L. Resistance, area of the conductor, length of the conductor. SI units ohm meters. SI units ohm meters. Now reciprocal of resistivity is called conductivity. It is opposing, it is allowing. Based on opposing, it is allowing. Now reciprocal of resistivity is known as conductivity. Now the value of resistivity of the material determines conductivity of the material. Now for example, metals, if you take metals, it has low resistivity. Metals with low resistivity acts as a good conductors. If resistivity less, it will allow the more electricity. If you take insulators, resistivity of insulators 10 power 14 to 10 power 16 ohm meters. For insulators, it is very high. Higher order, high resistivity. For insulators, resistivity is high, 10 power 14 to 10 power 16 ohm meters. If you take semiconductor like silicon and germanium, it has 10 power 5 to 10 power 10, 10 to the power 5 to 10 to the power of 10 times more than metals. It has the resistivity 10 to the power of 5 times to 10 to the power of 10 times more than that of the metals, and less than 10 power 15 to 10 power 16 times. Semiconductors has the resistivity that is more than metals, 10 power 5 to 10 power 10, and it is less than that of the insulators. 10 power 15 times to 10 power 16 times less than that of insulators. Semiconductors. Now if you take filament, Filament of the bulb more made with material tungsten. Made with tungsten because it is a higher resistivity and higher melting point. That is 3422 degree Celsius. It is used in filaments of electric bulbs. Filaments in electric bulbs. Okay. Thank you for watching. Please subscribe.